Hello, and welcome to your delightful dreaming. Perhaps you've spent the day looking up at that distant red dot in our sky. Or maybe you're someone who finds peace in imagining worlds beyond our own, rather than tossing and turning with earthly worries. Whatever brought you here, this evening's voyage is crafted just for you. When you look up at Mars in the night sky, you see that distinctive reddish glow that earned it the nickname, the Red Planet. But here's the thing, Mars isn't actually red all the time, and it's definitely not uniformly red across its surface. The red color comes from iron oxide, basically rust, covering much of the planet's surface. But if you were standing on Mars, you'd see a much more diverse color palette. The sky can appear blue during certain times of day, just like Earth. The sunsets, they're actually blue on Mars while the rest of the sky glows reddish-orange, the exact opposite of what we see on Earth. And those rusty red plains, they're mixed with dark volcanic rock, white polar ice caps, and even greenish areas where different minerals are exposed. So while we call it the Red Planet, it's really more like the sometimes red, sometimes blue, sometimes white planet. But that doesn't have quite the same ring to it, does it? Think Mount Everest is big. Well, Mars laughs at Mount Everest. The planet is home to Olympus Mons, a volcano so massive it makes our tallest mountains look like tiny hills. How big are we talking? Olympus Mons is about 13.6 miles high. That's nearly 3 times the height of Mount Everest. But here's the crazy part. It's not just tall, it's wide. The base of this volcano is roughly the size of the state of Arizona. You could fit the entire chain of Hawaiian islands inside it with room to spare. And get this, if you were standing on the base of Olympus Mons, the peak would be beyond the horizon. The volcano is so large that its slope is so gradual, you wouldn't even realize you were climbing a mountain until you looked at your altimeter. The reason Mars can support such massive volcanoes is because it doesn't have plate tectonics like Earth. On Earth, our continents drift around, but on Mars, volcanic hotspots can keep building up in the same place for millions of years. It's like having a really persistent pimple that just keeps growing. Here's something that might surprise you. A day on Mars is remarkably similar to a day on Earth. While Earth's day is 24 hours, a Martian day, called a sol, is 24 hours and 37 minutes. That's only 37 minutes longer. This similarity is purely coincidental, but it's one of the reasons why Mars is often considered the most Earth-like planet in our solar system. However, don't let that fool you into thinking the years are similar. A Martian year is 687 Earth days long, nearly twice as long as our year. This means that Martian seasons last about twice as long as Earth seasons. Imagine winter lasting for 6 months instead of 3. That's a lot of holiday shopping time, but also a lot more heating bills if you lived on Mars. The similar day length is actually really convenient for the scientists who operate Mars rovers. They can work on Mars time without completely destroying their sleep schedules. Well, mostly. Mars has 2 moons, Phobos and Deimos, but calling them moons is being generous. They're more like captured asteroids that look suspiciously like flying potatoes. Phobos, the larger of the two, is only about 14 miles across at its widest point. Deimos is even smaller at just 8 miles across. To put that in perspective, you could drive across either moon in less than an hour. Our moon is 2,159 miles across. It's not even a fair comparison. But here's where it gets interesting. Phobos is actually falling toward Mars. It's getting about 6 feet closer to the planet every century. In about 50 million years, Phobos will either crash into Mars or break apart and form a ring around the planet. So Mars might eventually have rings like Saturn, which would be pretty cool. Deimos, on the other hand, is slowly drifting away from Mars, just like our moon is drifting away from Earth. So Mars is simultaneously losing one moon and gaining a potential ring system. It's like cosmic juggling. If you thought Earth's hurricanes were bad, wait until you hear about Martian dust storms. These aren't your average windy days. We're talking about storms that can literally cover the entire planet for months at a time. These global dust storms happen roughly every few years and can last for weeks or even months. During these storms, the sky becomes so thick with dust that it's like permanent twilight. Solar-powered rovers have to go into hibernation mode because there's not enough sunlight getting through. The winds during these storms can reach up to 60 miles per hour. Now, that might not sound too scary compared to Earth's hurricanes, but here's the thing. Mars's atmosphere is much thinner than Earth's. Even though the winds are fast, they don't pack the same punch. You could probably lean into a Martian dust storm and not get knocked over. But the dust? That's a different story. Martian dust is incredibly fine and gets into absolutely everything. It's also electrostatic, meaning it sticks to surfaces like crazy. Future Mars astronauts are going to have a real problem keeping their equipment clean. This is probably one of the most exciting discoveries about Mars in recent decades. We now know that Mars once had liquid water flowing on its surface, lots of it. We can see dried up riverbeds, lake deposits, and what appear to be ancient ocean shorelines. But where did all that water go? Some of it evaporated into space because Mars's atmosphere is too thin to hold onto it. Some of it is locked up in the polar ice caps, and some of it might still be underground as liquid water. In 2018, scientists discovered what appears to be a large underground lake beneath Mars's southern ice cap. It's about 12 miles across and hidden under nearly a mile of ice. If it's really there, it would be one of the largest bodies of liquid water on Mars. Why is this exciting? Because where there's liquid water, there's a possibility of life. Not little green men, but maybe microbes or other simple organisms. It's like Mars is hiding its own little secret swimming pool. Mars has polar ice caps just like Earth, but they're much more interesting than ours. While Earth's ice caps are made entirely of frozen water, Mars's ice caps are layered like a cake, with alternating layers of water ice and dry ice, frozen carbon dioxide. During Martian winter, the dry ice layer grows as carbon dioxide freezes out of the atmosphere. During summer, it sublimes, goes directly from solid to gas, back into the atmosphere. This seasonal cycle is so dramatic that it actually changes the atmospheric pressure across the entire planet. The water ice layers tell us about Mars's climate history, kind of like tree rings tell us about Earth's climate. Scientists can study these layers to understand how Mars's climate has changed over millions of years. And here's a fun fact. If all the dry ice at Mars's south pole sublimed at once, it would double the thickness of Mars's atmosphere. That's a lot of frozen CO2. This is the big question that keeps scientists up at night. Did Mars ever have life? The short answer is, we don't know, but it's looking increasingly possible. Mars had all the ingredients for life as we know it: liquid water, organic compounds, and energy sources. Recent discoveries have found complex organic molecules in Martian soil and rocks. The Perseverance rover is currently collecting samples that might contain evidence of ancient microbial life. But here's the really exciting part. Life might still exist on Mars today. If there really are underground liquid water reservoirs, and if life ever got started on Mars, it's possible that some hardy microbes are still hanging on in these subsurface environments. We're not talking about intelligent life here, more like the kind of extremophile bacteria we find in Earth's most hostile environments. But even finding microscopic life on another planet would be one of the most significant discoveries in human history. Mars's atmosphere is about as hostile to human life as you can imagine. It's 95% carbon dioxide, with tiny amounts of nitrogen and argon, and virtually no oxygen. But the really scary part isn't the composition, it's how thin it is. Mars's atmospheric pressure is less than 1% of Earth's. That means if you stepped outside without a pressure suit, your blood would literally boil. Not from heat, but from the lack of pressure. It's like being in the vacuum of space, but with a tiny bit more atmosphere. This thin atmosphere is why Mars can't hold on to liquid water on its surface. Water would either freeze or boil away depending on the temperature. It's also why those dust storms we talked about earlier can't actually knock you over despite their high wind speeds. The thin atmosphere also means virtually no protection from radiation. Earth's thick atmosphere and magnetic field protect us from harmful cosmic rays and solar radiation. On Mars, you'd be getting zapped constantly. Mars has seasons just like Earth because it also has an axial tilt, about 25 degrees compared to Earth's 23.5 degrees. But Martian seasons are much more extreme and, bizarrely, uneven in length. Because Mars's orbit is more elliptical than Earth's, it spends different amounts of time at different distances from the Sun. This means Southern Hemisphere summer happens when Mars is closest to the Sun, making it shorter but more intense. Northern Hemisphere summer happens when Mars is farthest from the Sun, making it longer but milder. The temperature swings are also extreme. Summer temperatures at the equator can reach a pleasant 74 degree, 20 degree course, but winter temperatures can drop to 195 degree, 125 degree course. That's a swing of more than 260 degrees, enough to freeze carbon dioxide right out of the atmosphere. And remember, each season lasts about twice as long as Earth seasons, because the Martian year is 687 days long. Imagine dealing with winter temperatures of 195 degree Celsius for 6 months straight. Humans are absolutely obsessed with Mars, and the numbers prove it. We've sent more spacecraft to Mars than to any other planet. Over 50 missions from various countries since the 1960s. But here's the thing about Mars missions. They're really, really hard. About 2/3 of all Mars missions have failed. Mars has earned the nickname the Galactic Ghetto because so many spacecraft have met their doom trying to get there. The problem is that Mars is just far enough away to make everything difficult. It takes 6 to 9 months to get there, depending on the orbital alignment. There's only a launch window every 26 months when Earth and Mars are properly aligned. And landing on Mars is incredibly challenging because the atmosphere is too thin for parachutes alone but too thick to ignore. Despite the challenges, we currently have multiple active missions on Mars. Rovers, orbiters, and landers all working together to unlock the planet's secrets. It's like we've set up a small scientific outpost on another world. This isn't science fiction anymore. Multiple space agencies and private companies are seriously planning human missions to Mars. NASA aims to land humans on Mars in the 2030s, and SpaceX has even more ambitious timelines. But getting humans to Mars safely is a whole different challenge than sending robots. The journey would take 6 to 9 months each way, exposing astronauts to dangerous levels of cosmic radiation. They'd need to bring enough food, water, and air for the entire mission, or figure out how to make these resources on Mars. The psychological challenges might be even harder than the technical ones. Imagine being confined in a small spacecraft with the same people for months, knowing that Earth is just a tiny dot in the distance and that no rescue mission could reach you if something goes wrong. But the potential rewards are enormous. A human mission to Mars would be the greatest adventure in human history and would likely lead to permanent human settlement on another planet. We're talking about making our species truly interplanetary. This might sound like science fiction, but many scientists seriously consider Mars as a potential backup planet for humanity. Not because Earth is doomed, though climate change is a real concern, but because it's good survival strategy to not keep all our eggs in one planetary basket. Mars has several advantages as a potential second home. It has a 24-hour day cycle. It has seasons. It has water, frozen but still there. And its gravity is about 38% of Earth's. Weak enough to be manageable but strong enough to prevent the bone loss that astronauts experience in zero gravity. The challenges are enormous though. We'd need to terraform the atmosphere or live in enclosed habitats. We'd need to solve the radiation problem. We'd need to establish reliable food and water sources. And we'd need to develop technologies that could be manufactured and maintained entirely on Mars. But even if we never terraform Mars, establishing a self-sustaining human colony there would ensure that human civilization could survive planetary disasters like asteroid impacts or supervolcanic eruptions. It's the ultimate insurance policy for our species. The dream of humans living on Mars might seem impossible, but remember, just 120 years ago, human flight seemed impossible. Now we have people living in space stations. Mars might be the next logical step in humanity's greatest adventure.